What happens is that the hardware innovation goes faster than how the blockchain can grow. We just recently had these release new CPUs and new architecture of RAM and the PCIe that is like doubling the performance of hardware computing. So you have this AMD Zen 4, which can go up to 4 gigahertz of clock speed, DDR5, 2 times faster than the last generation. You have PCIe 5, which is 2 times faster than last generation. So the bet of the high throughput blockchains that, okay, we need a massive amount of computing, but this computing will be improved. They will get faster and cheaper over time.
Really appreciate you joining, Gui. You're really one of the true, I would say, leading experts in running the blockchain node infrastructure. There's not very many people that I would say have as of a handle on the infrastructure, the bandwidth requirements, the different compute as you do. And I think today where I really want to approach this conversation from is from the hardware point of view. You have a unique insight into that lens through the blockchain world that I think many people do not get to see. So really excited to have you on and really looking forward to this conversation. Thank you so much for joining me.
Thanks a lot for having me, Logan. And I think people likes much better the softer side of things, right? It seems to be more cool, but it seems I am an exception there. I I really love hardware and not networking kind of stuff.
I'm a big hardware nerd as well. I think in the blockchain world, it's underappreciated. So again, thank you for coming on and excited for kind of all the insights that you will share. Maybe just briefly, could you do a quick background on yourself, how you got involved in the hardware, how you kind of came into the blockchain world?
Cool. Yeah. Yeah. I am. My journey started actually when I was 9 years old. It was in '94 when I got my first computer from my father, and this was an era before the internet existed. Probably most of the audience will not is not familiar with BBS, bulletin board system, but that was my first interaction with the internet. It was fascinating. Uh, it was a terminal all in green that you use it to chat and exchange files. We didn't have browser, and you had to dial up to the broadband provider. and yeah, and but I was since I got to the BBS world, I was fascinated with internet, and I knew that I wanted to have a career in tech for my whole life. And before we had this massive adoption in the internet, right? And yeah, and then I found I always liked to create business, and I founded my first business when I was 13 years old. It was a niche search engine that I got paid by clicks, and it was amazing. I was making a lot of money. My dad didn't get much what I was doing, and he was a car dealer and wanted me to work with him, but there was no way. I always loved it,
You
computer
were
and internet.
hustling from the early beginnings.
Yeah, exactly. And yeah, this was my first business, and I had many other ones after that, which all many of those failed. And uh, and then fast forward to 2023, I run a company called Latitude, which is a bare metal cloud provider. Uh, um, uh, Latitude provide computing infrastructure in 15 different locations around the globe. Um, so we make it easy for especially high throughput applications to deploy distributed global computing for their specific use cases. Um,
I think, I mean, originally how we ultimately got in touch with you is through our portfolio companies. We were talking with a lot of RPC providers, people in our portfolio company that were looking for better RPC nodes. And oftentimes, what we found after talking with quite a few teams is that they had redundant partners because often the infrastructure was so bad. And then when we started chatting with you, it was really kind of night and day difference what they saw on the performance side. And it's been amazing to kind of work with you even closer, see what you're doing behind the scenes and the operations that you're running, because it really is extremely impressive. The hardware is always changing, the requirements are always changing. So kudos to your team for keeping at the forefront of the industry on that.
Thanks a lot, Logan. And yeah, and how we got into the blockchain. We Latitude use it to provide computing for many Web 2 applications, high throughput Web 2 applications. And uh, at one point, a company, which is still our customer, came to us asking for specific hardware configurations. And I look at their website, and they were a crypto company. And I was really interested to go deeper on that because before providing services to blockchain in the blockchain space, I was an enthusiastic of the crypto world. I was for a long time playing with Bitcoin, Ethereum, smart contracts, and all that kind of stuff. I always find it fascinating. And when I had the opportunity to provide computing under the company to the blockchain, it was really cool. And I think the reason uh, why we provide good service for because we really understand the needs, the different needs for uh, uh, of the space. And I think most of the competition don't care because crypto is still too small, and there are many other verticals going on, right? But uh, as I like, and as my team also like crypto, we got deeper in the space.
100%. No, crypto is a fascinating, I would say, never ending rabbit hole where you learn something and then you kind of peer in and then you're like, oh, there's another thing I have to learn. And it's kind of, it's never ending. And so, again, kudos to your team for kind of understanding the opportunity here. And now I think you're one of the larger providers in the space on the node operation standpoint. And again, like you provide very high throughput machines. You offer a variety of different hardware to different blockchains. And that's where I would love to maybe start the conversation and kind of frame. I think you have a unique point of view from the hardware standpoint that's not necessarily strictly software consensus and everything that's happening on Twitter. So maybe starting the conversation, could you talk on some of the differences that you've seen, maybe from a hardware point of view, from like these high throughput blockchains to some of the earlier blockchains that existed in the space?
Yes, sure. Um, we have, I think we have two sections right now. Actually, two categories. One category that category of hardware that fits in high throughput blockchains, and another category that would fit in the low throughput blockchains. So they are really similar. So if you get like Solana, say Aptos, Sui, they share the same hardware spec in general. Actually, Solana has a higher requirement as it's the single high throughput blockchain that got some traction and users and volume, but the requirements for these other high throughput blockchains, they are nowhere near the low throughput blockchains. So yeah, we have on the high throughput side, we have faster cores. So it doesn't it's less related to amount of cores, but more related with how fast these cores are, right? And that's why the usually the public clouds are not a good fit for these high throughput blockchains. But I think we can go uh, on that later.
Yep.
And yeah, on the memory side as well, you need more memory, you need faster drives. So you cannot run high throughput blockchains on standard drives or SSD drives. You really need NVMe, and you need a high throughput network infrastructure, and preferably like 10 gig NIC in your server. NIC is a network interface card.
Interesting. So, in the first category, maybe just to articulate, in the high throughput blockchain camp, you have Solana, Sui, Aptos, Say Network, where they require a large amount of bandwidth, and then ultimately have faster cores. They have more RAM. And also extremely fast storage to store all that kind of high throughput data. And then in the second camp that you've seen on kind of the earlier generation blockchains, what type of hardware are they running there?
They are running like between 8 to 16 cores. That's the recommended spec. So they run between 8 to 16 cores, but they don't have a requirement for fast cores. So you can easily run on any public cloud or any commodity hardware. Like if you have a 2 gigahertz computing CPU, but if you have the 8 core, it will be okay. SSDs and the bandwidth requirements are the lowest. That's why you can run Ethereum node at your home or at really low speed internets.
Yeah, it is interesting. I think the hardware requirements are a fascinating kind of lens at evaluating the blockchain space, and one that I think is kind of underappreciated, just because everybody's normally focused on purely kind of the software and the consensus. And so it's a unique lens. Just again, kind of the newer blockchains that are coming online have higher throughput, have higher cores, faster cores, and more RAM, more storage. And then the earlier generation of blockchains have lesser hardware. The requirements for speed are just less data bandwidth. It's very fascinating.
Yeah, and the hardware requirements for the high throughput blockchains, they always start at a baseline, uh, but the actually the network usage actually just get higher and higher when there's volume. So I'll give you a practical example. You have Solana, and you have nodes that are just to keep up with the tip of the network, you need like 150 megabits per second. And in Sui that just launched, that's not the case. It will use really low bandwidth just due to volume. But we expect that to grow as the volume on the chain grow.
100%. And this is what I always say to the people that ask me about kind of these other high throughput blockchains outside of Solana is I say they're all kind of Ferraris, but you can't teleport to 200 miles per hour. You kind of have to slowly get there. And the demand component is really the important thing. They have the capacity to support that. You can scale the hardware on the back end, but you really need the demand in the application. And again, I think with Solana having the community that it does, the active users on chain highlights the demand for more hardware today.
Yes, exactly. There are some specific use cases on Solana that you need 1 terabyte RAM machine, which is a lot. And if you want to provide, this is actually more used by RPC providers when they want to provide fast requests to their users through APIs and to run all the indexes and the program IDs that Solana has. They store in RAM to for the data retrieval to be faster. So they need 1 terabyte of RAM right now. It's pretty massive.
That is pretty crazy. It's
Yeah.
very interesting to me just how these requirements are going to grow over time on these high throughput blockchains versus some of the earlier blockchains. I think at the end of the day, there's a lot of different architectures from the software side trying to different things, whether separating the data or separating the compute. But I don't think there's any way around at to really scale to increase the amount of bandwidth that is going to be required and the amount of compute. You can kind of separate those layers on the software side, but at the end of the day, the compute and bandwidth have to happen somewhere to actually scale.
Yeah, that's true. You're probably talking about FireDancer, right? It's a new client that is being built by Solana. For example, they are trying to push more throughput to Solana while using less hardware. And yeah, I think with the growth of the blockchain, the growth, and when we onboard. Uh, the next million, or I hope the next billion people to crypto. There are many of these optimizations on the software side going on that will definitely improve, and on the hardware side, even with all these software optimizations, we still should see um, growth of the hardware requirements and the network requirements for these high throughput blockchains. But what happens is that the hardware innovation and the hardware innovation goes faster than how the blockchain can grow. So we just recently had this release for new CPUs and new architecture of RAM and the PCIe that is like doubling the performance of hardware computing. So you have this AMD Zen 4, which can go up to 4 gigahertz of clock speed. Actually, we just moved our validator to this new hardware, and we are about to see how the performance will be increased in the next few epochs. And you have DDR5, which is 2 times faster than the last generation. You have PCIe 5, which is 2 times faster than last generation. So the bet of the high throughput blockchains is that, okay, we need a massive amount of computing, but this computing will be improved. They will get faster and cheaper over time. And I think that's what Anatoly is repeating on and on, right? The Moore's law, where you have every 2 years you have double the amount of computing capacity for half the cost. Is something like that.
It's a great point that you bring up. It is rather remarkable, just that even outside of the blockchain industry, there is a whole nother industry, the hardware industry, kind of pushing forward on the things that you mentioned, PCIe with the bandwidth connections, adding more cores, upgrading different RAM specs. It's all kind of pushing forward even outside of what we're doing independently of the blockchain world. And it's fascinating and ultimately helpful because it allows us to scale. Once the demand is really there, you can kind of switch out the parts as you have been doing on your recent node operations and just upgrade those. Maybe
Yeah,
one thing though that
there's one point that sorry interrupting you, Logan, but there's one other point that I forgot to mention is the network, and as we get volume to these high throughput blockchains, we will see a massive usage of bandwidth, right? Right now, it's already intensive, like I said, 1,200 megabit per second on a high stake node or a RPC node that is busy enough. But what happens is that the internet pipes are getting bigger over time and they are getting cheaper. So we have transit agreements. We have to buy internet from internet providers across the globe for our operations, right? And let's say Comcast, we buy internet from Comcast, and we have like 1 terabit of committed traffic with them. And year over year for the last 20 years, they are getting, we can get double the capacity for half the cost. So that's how internet is going to, so how is the high throughput blockchains will be able to scale without concerning much about bandwidth. Yeah.
it's pretty remarkable. I mean, all the pieces are kind of coming together in the sense that hardware improves. And the biggest bottleneck, I think, in all blockchains is that communication overhead, being able to come to consensus, being able to add more transactions per second. And at the end of the day, that's how much data you can kind of propagate across the network. And so, understanding that these things naturally continue to grow over time and get cheaper is paramount. But one thing that you mentioned initially was kind of talking about the pros and cons of setting up a blockchain on a public cloud infrastructure. You said the lower throughput blockchains are with lower requirements are fairly easy to run on these cloud infrastructures, but the high throughput blockchains, they don't really work that well in these cloud infrastructures. Could you maybe share a little bit more about like the pros and cons?
Yes, sure. So the public clouds, usually the big three, right? They build machines with CPUs that are for general use. So they make this big machines for any type of use case, right? And the CPUs has a lot of cores, so they have 128 cores, 256 cores, just massive. But you have really low core speed, and that's one point that can drastically impact performance of especially high throughput blockchains. Uh, there's one other point as well. These servers are virtualized; they are multi-tenant, and you have workloads competing for resources, and that's not predictable for and that can be sensitive for high throughput blockchains. You need to have really consistent speeds on the CPU, so you don't fall behind the network and affect the application. There's another point as well, that is cost. That's a big one, because to get access to big machines on the public clouds, you will break the bank. And not only computing resources, but the network that you need there will be massive as well. Especially for Solana, as we were discussing, we are doing like 1,200 megabits per second on a high stake node. You would spend like 20K a month for something like that. So that's meaningful.
On
right?
just particularly bandwidth costs, being like ingress and egress the most expensive thing, or also in addition to the compute?
Compute is really expensive, but the big component is definitely egress. Yeah, actually, no clouds nowadays charge for ingress, so you are always paying egress. That's pretty standard. But
And egress for the non-technical people is just outbound traffic, correct?
yes, correct. Yes, the traffic that goes from the machine to push it to the internet. And the reason that clouds only charge for the egress because they you are hosting content in the machine and you are providing data to the internet. So it will always be higher than ingress.
Interesting. No, it is fascinating.
Um, yeah, and there's pros as well, right? So you have on public clouds, you have a massive amount of computing available that you can get access to at any time, and you don't need a massive amount of human resources. They offer like managed servers that you can use. Elasticity is one as well. So let's say the chain is growing, you can expand your memory or CPU on the fly without getting a new machine on a bare metal provider, right? That's I think that will be the pros of running blockchain nodes on virtualized and the hyperscalers.
Yeah, no, it's it's its own rabbit hole in itself. Just the different kind of nuances between running in a public cloud, and especially as you mentioned on these high throughput networks, they need more compute resources. They need dedicated cores to understand the workloads. Uh, but those cores also need to be fast. And at the end of the day, that egress, because blockchains are ingesting data that is sent to them by the network, but also sharing out information on confirming consensus, sending out transactions, that can be costly in those cloud infrastructures and just make it, as you said, prohibitable to run from a cost point of view. Maybe talking a little bit about like the lower throughput blockchains, have you seen more people kind of opt for these cloud providers with the lower throughput blockchains because they just have lower hardware requirements and not a lot of outbound bandwidth?
Yes, there's the low throughput blockchains are the public clouds are more compelling to them for sure. Like a lot of the EVM chains, Avalanche, there are many nodes running on AWS. Not that is AWS, Azure, and GCP, right? Not that is. It's still more expensive, but I think the pros there sometimes make sense for them just to spin it up a node. And sometimes they have other applications, managed applications running in the public clouds as well. So it just makes sense to have them running all together.
Yeah, no, I find the hardware aspect just as interesting or more interesting than the software side because there are a lot of small nuances. You have to understand when the hardware upgrades are coming, how often you need to do that, if the demand is going to be there. Hardware is always getting better, faster, cheaper. As we mentioned, it's it's a fast moving space.
Yeah, it is. And there's a lot of challenges on our side with that too, because the one thing that we are seeing that is growing across all the chains is the consumption for storage. And we have built some specific machines uh, that are purpose built for blockchains, but they are changing all the time, and we have to adapt them across the locations to make sure they fit the needs. And on the physical infrastructure is a bit more challenging than just adding drives to a hypervisor and making the virtual machines bigger, right?
Yeah, it's the storage aspect I think is just now like starting to be a little bit more of a consideration on these high throughput blockchains. On the lower throughput, again, like the amount of data that they're actually propagating is relatively small. I think on orders of like 1 or 2 terabytes, but on Solana specifically, I think once their network capacity, the average workload is, say, 1 gigabyte or 1 gigabit per second. I think the expected amount of storage is 4 petabytes per year, which is a lot, 4,000 terabytes of storage. And so you can see how the amount of storage, the compute demand, the bandwidth expectations on these high throughput blockchains are just worlds different than kind of what we earlier imagined in some of these first iteration of blockchain networks.
Yes, that's true. Like you cannot run an archival node on Solana on a single node. That's something that you cannot do because Solana is producing blocks at every 400 milliseconds. It's producing a lot of data, and I think it has to do with the architecture that is built. But we already have like over 200 terabytes of data on Solana. So you cannot have that on in a single server.
It is fairly large, and again, I only expect the data to be increasing on these high throughput blockchains. One thing I think that we kind of talked about earlier as well is some of data centers, or at least that I've observed, are starting to ban crypto. Can you talk about why these data centers are kind of anti-crypto and why this is happening?
Yes, that's a really great point. And the it comes down to business model. So most of these data centers that are banning crypto, they do a business model where most of their users are not using the resources they are allocated. So you have computing, you have a network, and when you start using this computing and network at scale, you are wearing out the drives faster. You are generating more bandwidth on the network for the data center. You are using more of their power. So the business model just don't work, right? You were renting a bare metal machine for $50, and you get a Solana validator operator there with a huge load on the machine 24/7, producing blocks and validated transactions and all that, and it's been generating loss, right? And after a year, the drive is gone because you store the accounts on drive, on the NVMe drive. You were serving these requests from the NVMe. It's really intensive, and the data center has to replace this drive after a year. I think that's the only reason they are banning crypto.
So maybe on that front, if the data model is not working for, I would say, some of those generic providers that are running these bare metal operations, how is the data or how is the business model working for Latitude, and how are you able to make it work on your end?
Yeah. Price, right? Cost. There is no way around. We are still really competitive in terms of pricing. If you compare with the competitors or the hyperscalers or even the bare metal providers, we are providing a good price point, but you cannot run a node for a high throughput blockchain for a couple bucks, right? So that's just not possible. Comparing to these providers that were that banned crypto, we are like 2 times more expensive. And although the hardware is more performatic, they can perform better. And we are already accounting that the disks will be wear out after a year, and this is already part of the business model. So we welcome crypto and welcome high throughput blockchains.
Wonderful. It really is to me a complete paradigm shift and really an appreciation for a different amount of scale that these high throughput networks are trying to achieve by having much more bandwidth, by having more compute, by having these faster drives, more RAM. They're all components, I think, good components and good problems to have once you actually reach user adoption. And I think today people often forget the blockchain industry as a whole is very small in terms of one, the amount of kind of dollars flowing in the ecosystem compared to other asset classes, but two, just on a user adoption front. And so I personally very much welcome kind of having these higher requirements to ultimately get to scale and get the industry growing.
Yeah, and I think everyone should push the to the limits and improve TPS. I think you can ask like, why do we need a new client on Solana, or why do we need the chain to be faster, as we don't have the adoption yet, or we don't have enough users using the network. We have a lot of block space available that users could use, and dApps could be built, right? But what happens is, when you have the technology, when you have a faster hardware, when you have a faster throughput internet or blockchain, you get the users, you get the applications built with the resources that are available, right? When when we had the BBS and the dial-up to download an image that took like minutes to download a JPEG, you had the developers or the people optimizing for the resources that was available on that time, right? And
100%.
yeah,
And I think, I mean, we see the same thing today in the blockchain world on Ethereum. Like people are trying to even remove like slight security constraints to save on a couple bytes to make the contract cheaper. Where I think if instead, if you focus, as you mentioned, on just scaling the underlying network, kind of the analogy that we use in at Frictionless is going from 56K modems to broadband to fiber optics. You had the early days of the internet with Bitcoin and self-sovereignty. Then you had Ethereum expand upon that with smart contracts. And now you're getting these high throughput networks that have smart contracts and can scale and kind of keep everything kind of composable. It makes the world easier, and engineers can build cooler things, as you mentioned. And I think that is really what's truly needed. I think the people that say the demand for block space is not there today, why should we scale block space, are the same people in the 90s that would have said, let's just stick with 56K modems.
yeah, that's it. Correct. I 100% agree. And it's a lot of waste optimizing for less resources, right? You are spending a lot of human resources on that, while the tech is there, right?
100%. Maybe I think one, I would say, not caveat, but frustration or misconception that the low throughput blockchains have about the high throughput blockchains is maybe that they're not as decentralized from a global standpoint, because they have higher hardware requirements, because it's not as easy to run at home. You need higher specs. Can you talk about specifically Latitude and how kind of global and diverse your offerings are on the node side, from like where you guys have these nodes running in what parts of the world, and how decentralized is the Latitude network itself?
Yeah, cool. So we operate in 15 different locations in continents. We are in South America, in North America. We are in we have a presence in Australia, in Tokyo, in United Kingdom, in Europe, and all of these pops, they are independent. So they operate with their own providers, actually transit providers and network infrastructure. Um, so if we have a disruption in one of these pops, they our other pops will not go offline. Yeah, so our network is distributed and decentralized from that point of view. Um, but I think the blockchains and the node operators, they still need to decentralize everywhere they can, right? Run on multiple providers, things like that, because that's the main point of Web3 decentralization. And I think there's one concern on having a lot of stake and dApps being hosted in the big tree, because you were getting the same concentration of power that we have in the web 2. That's not the goal, right? We want to have blockchains that are there that use a ton of different entities and providers.
And I think the comical thing here, as we talked about earlier in the podcast, is these higher throughput blockchains, just because they are more expensive in the structure of the current cloud providers, are almost necessitated you run them on bare metal, which at the end of the day, I think one can make a arguing and compelling case will make these networks more decentralized from a geographic standpoint and also a provider standpoint, because you have to run them just from a cost standpoint outside of the cloud infrastructure.
Yeah, that's true. You have these higher end specs you cannot run at home, right? But if we take Solana for example, that there's a repetitive narrative around Solana that the that is not decentralized, but we already have Solana already has like 3,000 nodes, 3,000 validator nodes across 200 different data centers. You don't have most of the blockchains out there. They have 100 validators, 150 total validators, and we are talking about 200 different data centers across 3,000 nodes. So I think it's possible to decentralize the high throughput blockchains. This is something that is not true, and I think people with other incentives that are pushing this message.
Yeah, Twitter is a funny space. I think a lot of people are just ultimately misinformed. But the other thing is the space just moves super fast, and it's personally hard to stay up with all the different architectures, even the hardware, how that's progressing, the software side of the things. There's monolithic architectures, there's modular. Everybody likes to debate all these things, and it's hard to understand the nuances. So I can definitely appreciate or sympathize that the facts are not always relevant, or at least apparently obvious on the surface. But I think, as you said, if you look a little bit deeper, Solana is one of the more decentralized chains, I think, outside of Bitcoin and Ethereum. And the world, I think, is slowly learning. So I think it'll just take some time.
Yeah, I agree.
Maybe one other interesting kind of hot topic in the world has been AI, just being a bare metal compute provider. What have you seen kind of spin up on the AI side of things now that it is the hot topic?
Yeah. So we recently saw NVIDIA stocks spiking 30%, right? We usually see those spikes in crypto only and not traditional markets, right? But this was expected and came out after their first quarter earnings call. And because the amount of GPUs that are being sold is just massive, and these GPUs are going to AI and machine learning space. We are really excited getting into this space, because talking to people and working with customers that are building uh, new use cases around machine learning is just fascinating. We are working with a customer that has built a software that provides information in real time on a soccer match. So it provides the ball acceleration, which soccer player has the ball, or like a ton of data that they can get in real time for users, and that's really cool. And yeah, we built two machines that are appealing for the AI space, built with the NVIDIA GPUs. And I think NVIDIA will dominate this space for the upcoming years because they have attracted a lot of developers that are developing on CUDA, and that's in my opinion that's why NVIDIA put like 200 billion cap in just yesterday. That's, I think it's more than Intel, right? So crazy.
The market cap has gone absolutely parabolic the last couple days. Yeah, the AI renaissance has been fascinating, and I think the interesting thing has been while you increase more compute and you add more data to these large neural networks, you get more interesting applications. And so the demand on AI side for these GPUs to train these neural networks have gone just crazy. Are you specifically at Latitude, do you have a core focus of just bare metal compute, or are you specializing in crypto or AI? How do you think of yourself at Latitude?
Yes, we provide foundational infrastructure for different applications. So it's not just blockchain. We are we are in gaming as well, in streaming, and now in the AI space. But we provide the bare metal without any kind of virtualization or managed services. We want to provide this computing infrastructure for for the developers and companies to build their applications on top.
Awesome. No, I think that you're in the correct business because your services are very much in demand, and I don't see that demand waning anytime soon.
Yeah, on the GPU side, there is a competition from the provider side to get access to the GPU. I think it's the first time that I see something like this. Um, we have to convince the vendors to sell us GPUs, and we try to get as much as we can, even without the having the. Actually, we have a waiting list for GPUs across many use cases inside the crypto as well, like ZK technology. They want to get access to crypto. Multiple teams are using a lot of A100s GPUs on clouds, and they cannot get access to more. And a lot of different use cases. And that's why you see you cannot find these GPUs available, and in the public clouds that has massive scale, you cannot find because the demand is so big that GPUs are not being produced enough.
It is insane. Are there, I mean, so outside of the zero knowledge space or even within it, is there demand for GPUs and any of the just like basic node infrastructure on high throughput blockchains today? Or is it primarily centered around the zero knowledge layer two aspect?
For all the teams that I spoke with, they are all doing ZK and using GPUs. And there are different use cases there too. Some ZK technology doesn't require a massive amount of GPU computing, like the ones that we are building on top. we are using the H100 that just came out, which is really powerful, but they are using like more generic and old GPUs. But you have other ZK technologies that use different type of architecture that they use these higher end GPUs. But I don't see other cases inside blockchains that are using GPUs right now. I don't think there's any.
Interesting. No, yeah, the whole compute space is fascinating. Just by, I think what I appreciate kind of about these high throughput blockchains is that they're relatively dumb. I would say from a outsider perspective, you increase the amount of bandwidth, you increase the amount of cores, everything kind of stays logically centralized in one giant shard. So it's easy for users, it's easy for developers. They get all the benefits that kind of blockchains provide with composability, and you can continue to scale.
Yes, I have used both blockchains, and the experience is just completely different on them, right? I think this first mover advantage that Ethereum had, they attracted developers to build on Solidity, right? And it's just really hard to them to port applications, and the users are already there. But I agree with you, the experience is just another level using any other high throughput blockchains. It's completely different than submitting a transaction you get instantly on the other side, and that open a lot of more use cases than just waiting for a transaction to settle for a couple minutes or
Yeah.
sometimes hours, and paying huge fees, right?
The fees are rough. I mean, and I think originally the ethos why I wanted to get into crypto personally was to kind of the democratization of some of the aspects that smart contracts allowed, such as DeFi, borrow lending, even doing the swaps, the basic trades on AMMs. Those functionalities are needed the most in kind of remote or third countries in the world, not really in the places that can afford to pay those high transactions. And so I definitely appreciate the high throughput blockchains kind of taking the burden of the high cost, putting it on the people like yourself, Latitude, for running those node operations and allowing the user experience to be just that much faster, that much cheaper. It's just a much better, cleaner experience, in my opinion.
Yeah, completely agree.
For those that want to reach out to you, I'll kind of allow you to show yourself, show Latitude, coming closer to the podcast. You run an amazing node operation standpoint. You have a breadth of knowledge in the hardware space. You also run RPCs, bare metal compute, you name it. What's the best way for people to get in contact with you and your team if they want to explore the nodes and how to work with the Latitude team?
I think the best way would be reaching out to probably sales at Latitude.sh, and we can get in touch. I think that's the best way.
Cool. Just head to the website. Makes it easy enough.
Yeah.
Well, thank you so much for coming on, Gui. Really appreciate you pushing the industry forward on the hardware side, your knowledge in being able to contribute to the hardware space, how all those kind of mechanics move. It's a whole different beast than the software side of the things, but I appreciate what your team and you have created at Latitude to help facilitate the industry grow.
Thanks a lot again for having me, Logan, and congrats. You're doing an amazing job on the podcast. Really fun.
Thank you. Well, I appreciate it again. Thanks, Gui.